Hello, thank you for joining me. This is section 3.1, graph in the form y equals mx plus b, part 2. So for this first one, I have graph y equals x minus 3. I think you should be able to do this one. I went ahead and just picked those points for no particular reason. I picked negative 6, 0, and 3, just because to get a good picture, I like to have a negative, 0, which remember 0 is that y-intercept. And then finally a positive, so I picked 3. And then all we have to do is just take our x values, plug it in, and get the y. So I've done the first one already. I went ahead, I had y equals x minus 3, put in a negative 6 for my x, negative 6 minus 3 equals negative 9. And then I plotted that on my graph here. I went over to negative 6, down negative 9, and plotted that first point. So right now, I'd like you to go ahead and hit pause real quick, plug in 0, 3, plot those next 2 points, connect them up with a line, come back when you're ready. All right, so when I plugged in 0, I got negative 3. When I plugged in 3, then I got 0. I went ahead and plotted those points, connected them up with a line, with a straight edge, put the arrows on the end, and that one is done. For part 2 here, for this next one, it says pick 3 points that lie on the graph of y equals x minus 3 that were not in your table. Do they satisfy the equation? So satisfy means doesn't make it true. Show your work by plugging in x and y into the equation. So let's go and pick some points. So ones that are on the line perfectly, they're going to go through those crosshairs. Okay, so the crosshairs, those are the lighter colored lines, like my grid. Okay, so I'm looking for points where the line goes right through that I didn't already choose before. So for example, if I look at 1, negative 2, okay, so try to find it before me so I don't cover it up. Do you see where the crosshairs are? So it goes right through where they line up. Okay, so I'm going to go and put the dot there. So that is 1, negative 2. Now look at negative 1, negative 4. Do you agree that that one also goes through perfectly? Yeah, so there's negative 1, negative 4 right here. And then finally 2, negative 1. So I went back over to the other side again. 2, negative 1. Looks nice. Of course, there's lots of different options. I just thought we could pick them together so that then you could check your work. Okay, so for part number 2, there's the 3 points that we picked. And now we want to go ahead and plug them into our equation to show that they're true. So for this first one, y equals x minus 3. My y is negative 2. So I'll put in negative 2. Does that equal x is 1 minus 3? I get negative 2 equals 1 minus 3 is negative 2. That is true. So hopefully these all work out, okay? Because we already said that they satisfy the equation because they're on the line, right? Now you go ahead and try the next 2. So hit pause, plug them into your equation, make sure that they work. And if they don't, go back and double check your signs, okay? So go ahead and hit pause, come back when you're ready. All right, so hopefully you got that the middle one there checked out. -4 equals -4. And finally, with 2 and -1, it also worked out. It was -1, -1. All right, go ahead and turn the page. The next one says pick 3 points that do not lie on that graph. Do they satisfy the equation? Show your work by plugging in x and y. So now we want 3 of them that are not on our line. So again, let's pick those together. Okay, so the first one I'm going to pick, I love picking 0 whenever I can because it wipes things out. Okay, so I'm going to include my 0, 0. Other than that, so many choices, right? Anything's fair game. Whatever you want to pick. If you want to follow along with me, though, for no particular reason at all, the next one I'm going to pick is -5, 5. Way up over here. And I'm also going to pick, no reason again, -1, 1. So you can see none of those are on the line. So hopefully when we go to plug them in, it does not work, right? Because the point of the line is it's showing us the infinite amount of possible solutions because all of these solutions are on that line. So I'm hoping that none of these work out. Okay, that's a good thing. So go ahead and plug in each of these. Verify that they are not true. Okay, so hit pause. Come back when you're ready. All right, so the first one got 0, does not equal -3. 5 does not equal -8 for the second one. And then that last one, 1 does not equal -4. So that's a good thing that they all came out as not true. So for number 4, it says, do all points on the line satisfy the equation? What do you think? Yes, that's the whole point, right? The line is showing us all the possible answers that will satisfy the equation. Next one, do all points not on the line not satisfy the equation? That's kind of wordy for me. Let me read it again. Do all points not on the line not satisfy the equation? Okay, so every point that's not on the line doesn't make the equation work, right? And we said yes to that, so that's good. So if it's on the line, satisfies it. If it's off the line, doesn't satisfy it. Number 6, the graph of an equation is sketched below. Which of the points represent ordered pairs that satisfy? Well, we just said it's all the points that are on the line, right? So which letters are on the line? B, C, and E. All you have to do for that one. Okay, the next one, it gets a little bit tricky with the fractions. Okay, so let's take a look at this one together. So number 7, graph y equals -2/3 x plus 1. And here I've picked the x values for us. I just picked -6, 0, 3. There is a reason why I picked those ones, and we'll talk about that in the next part. Okay, so let's just plug them in and see what happens. So I have y equals -2/3 x plus 1. And I want to plug in -6. So now I have -2/3 times -6 plus 1. Okay, I don't know about you. That looks kind of messy to me. Okay, there's a lot going on. So I'm going to do 2 different things to try to make it look a little bit prettier. First thing I'm going to do is instead of writing -6, to make it be another fraction, I'm just going to write it as -6/1 so that in my next step, I can see the cancellation a little bit clearer. The second thing I'm going to do is that negative sign, it can go way out front. And if you like it out there, totally cool, just leave it there. It could also float up top or on the bottom. So I'm going to rewrite it. I like to put it up top, -2/3. So again, that negative, it means the exact same thing, whether it's up top, on the bottom, or out front. You cannot put it both top and bottom, because a negative by a negative would be a positive. That would totally change it. Okay, so you just have to pick top, bottom, out front. Times, I'm going to keep that negative up top. Negative 6 over 1 plus 1. Now, the fractions are easier for me to see. Okay, so now I can see I have my top, the bottom, the numerator, denominator. I'm going to look at this 6. Let me draw a little arrow. The 6 and the 3. Could I rewrite 6 over 3? Could I reduce that? I could, because 6 over 3 is really just 2 over 1, right? So I'm going to write 2 over 1. Now, don't forget this negative sign, because now, if I look across the top, I have negative 2 times negative 2 is negative 4 over 1 times 1 is 1. And anything over itself or anything over 1 is really just that number, right? So it would look silly to put over 1. So it's really just negative 4. And then finally, plus 1. Oh, sorry. Negative times the negative. What is that? That should be a positive, right? I got too excited with the negatives. Let me erase that. There we go. Negative 2 times negative 2 is a positive 4. And then plus that 1. There we go. Which equals 5. So when x is negative 6, y is 5. So let's go try to plot that guy. It's about right there. Okay, 0. I always love 0. I'll write it in right here. So y equals negative 2/3 times 0 plus 1. Anything times 0 is just 0, right? And that's why I love that one. 0 plus 1 equals 1. So when it's 0, we're at 1. We'll plot that point. And finally, this last one is a 3. Okay, so I want you to go ahead and try to do that last one. Go ahead and hit pause. Write that 3 is 3 over 1. See if you can do some canceling, simplify, figure out what that point would be. Okay, come back when you're ready. Okay, so I went ahead and I put the negative up top again, just because to me it's a little bit easier for me to see. And then I have my 3. I like writing that over 1 so that I can see my fractions better. That helps me see that I can cancel out. 3 over 3 is really just 1 over 1. So I have 3 over 3 is really just 1. So now I have negative 2 times 1 is negative 2. Over 1 times 1 is just 1, so I won't include that. And finally, plus that 1. Negative 2 plus 1 is negative 1. So I'll go to 3 and negative 1. Plot that point. And let's go ahead and finish it off by finding that ruler again. Try your best to connect them up with a straight edge. Put your arrows on the ends. And we're done. So wasn't that nice that in these, that we actually got that whole number so it was easy to plot? So what if, like if somebody wanted to pick, just say like 4. If they wanted to plug in 4, let me rewrite this. So y equals negative 2/3. What if they want to put a 4 right here? So 4 over 1. Would that be okay? They get negative 8 over 3 plus 1. I mean, you can do that, right? You're going to get a fraction. I'm not really liking plotting the fractions. It's just a big mess. So what we want to do is we want to pick multiples of that bottom number. You want to pick multiples of the denominator because it will wipe out your fraction, right? So for example, if we had y equals, I'm just going to write 3/5 x plus 2. I just totally made that up. What would be some good x values to pick? I would go with, for my negative, I'd go with negative 5 because it would wipe out that 5. I still love 0 and then 5. What if you had y equals, let's just say 1/2 x. Okay, if that was what you had to work with. Your x values, you could go negative 4, negative 2, 0, 2, 4. I wouldn't go too big in the X values just because once you plug it in, it might kind of shoot it off of your grid and not fit in what I usually provides that little 10 by 10 grid. So, I mean, you can pick bigger numbers. You're just going to want to get some graph paper and make that bigger, okay? Or scale up your little 10 by 10 grid. Okay, so why is it a good idea to pick X values that are multiples of the denominator? And then I just went ahead and wrote it clears out the fractions, so it's easier to plot the points. Okay, hopefully that makes sense. Okay, one more to go. This one we have a lot of lines, and with the variables, it looks kind of messy to me. So I tried to color code them here. So it's talking about ax plus b. I just made blue. Then the second one I made green, and finally that last one I made red. So then it says decide which of the points satisfy the equation y equals ax plus b. So that was the one that I made blue, right? So if you look there at the blue one, what points are on that line? Because those are going to be the ones that satisfy it, right? You have B, works A, and E. All right, cool. Next one, which one satisfies both? Okay, so there's only one point that's on both the blue and the green line. What point is that? That's E. Okay, that's the only one that's on both the blue and the green. The next one says which points satisfy all three of the equations. So is there any point that's on all three of them? There is not, so we will just write none. And finally, do not satisfy any of them. So do you see any points that are on any of them? Yeah, that's C. All right, and I think that we made it. That's the end. I hope you have an awesome day. Bye.